In this video, we're going to focus on identifying oxidizing and reducing agents. What you need to know is that oxidation involves a loss of electrons. Reduction involves a gain of electrons. In addition, if the oxidation number increases, oxidation has occurred. If the oxidation number decreases, reduction has occurred. So let's try this example that we have on the board. What is the oxidation state of magnesium metal? The oxidation state of any pure element in its natural state is 0. So the oxidation state of elemental bromine is also 0. Now, in a compound, it can be different. Magnesium is in group 2 of the periodic table, and magnesium typically forms a +2 charge. Bromide usually has a -1 charge. And you can see in this formula, it takes 2 bromide ions to neutralize the +2 charge on the magnesium cation. So clearly we can see that magnesium has a +2 oxidation state, and each individual bromine atom has a -1 oxidation state. For magnesium, the oxidation state increased from 0 to +2. Because the oxidation number went up, oxidation has occurred for magnesium. Magnesium was oxidized. Now, bromine was reduced. Notice that the oxidation number for bromine decreased from 0 to -1, so therefore it was reduced. Now, the substance that is oxidized is also known as the reducing agent, and the substance that is reduced is also known as the oxidizing agent. Now, you might be wondering, well, why is that? Why is that the case? The reducing agent is the substance that causes the other element to be reduced. So magnesium is considered the reducing agent because it causes bromine to be reduced. On the other hand, bromine is the oxidizing agent because it causes the other substance, magnesium, to be oxidized. So make sure you reverse it. As long as you reverse it, you're going to get the right answer. So now, let's try another example. So consider this reaction. Zinc metal reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. Now, what I want you to do, I want you to pause the video and try this practice problem yourself, and then unpause it to see if you have the right answer. So let's begin. What is the oxidation state of zinc? For any pure metal in its natural state, if you have a pure element, it's 0. Now, in HCl, you need to realize that hydrogen usually has a +1 charge, and chlorine, like all of the other halogens like chlorine, bromine, iodine, fluorine, as an ion, they typically have a -1 charge. So the oxidation state of hydrogen is +1, and for chlorine it's -1. Now here we have elemental hydrogen gas. We don't have a compound, we have a pure element. So the oxidation number for elemental hydrogen is always going to be 0. It's 0 for any pure element. Now here we have a compound. Now we know that chloride has a -1 charge. So, and there's 2 of them, which means that zinc has to have a +2 charge. Now, if you feel a little unsure why zinc has a +2 oxidation state, you can write an equation. Zinc plus the 2 chlorine atoms should have an oxidation state of 0, because overall zinc chloride is neutral. So we're going to solve for the oxidation state of zinc. So let's replace zinc with an X symbol. And we know that chlorine as an ion has a -1 charge. So let's replace Cl for -1. So right now we have X minus 2 is equal to 0. So if we add 2 to both sides, we're going to get the oxidation state of zinc, which is +2. And so that's one way you can calculate it if you're ever unsure. So now let's finish this problem. So we see that the oxidation number for zinc increased from 0 to +2. So zinc was oxidized. It lost 2 electrons. Now, the oxidation state for hydrogen decreased from 1 to 0. so therefore it was reduced. The hydrogen atoms, or the hydrogen ions, they gained electrons, which is associated with reduction. Now, the substance that is oxidized is also known as the reducing agent, and the substance that is reduced is the oxidizing agent. So zinc is considered the reducing agent because it caused the other substance, hydrochloric acid, to be reduced. And the hydrochloric acid is the oxidizing agent because it caused the other substance, zinc, to be oxidized. So I hope that makes sense, but let's go ahead and try another example for the sake of practice. So let's say if we have sodium bromide plus chlorine gas, and it's going to produce a solution of sodium chloride plus liquid bromine. Now, go ahead and identify the oxidizing and the reducing agent. Sodium typically has a +1 charge. As an alkali metal, it's always going to have a +1 charge. Bromide is a halogen, and most halogens usually form -1 charges. Now, chlorine is a pure element, so it's going to be 0, and bromine, Br2, is a pure element. So now, which substance is oxidized and which substance is reduced? Notice that sodium is the spectator ion. The charge on sodium doesn't change, so we don't have to worry about that. Now, notice that for bromine, the oxidation state increased and went up from -1 to 0. So therefore, we could say the bromide ion within sodium bromide was oxidized. And if you look at Cl2, the oxidation number decreased from 0 to -1. And so we could say that chlorine was reduced. So therefore, chlorine is the oxidizing agent and sodium bromide is the reducing agent. If you notice, most metals like zinc and magnesium in the last two examples that we've considered, most elemental metals, they tend to form reducing agents. Like zinc and magnesium are good reducing agents. Most nonmetals in their elemental form, like Cl2, like chlorine, bromine, most nonmetals usually form good oxidizing agents, like oxygen, O2. Oxygen is a nonmetal, and it's a good oxidizing agent. In fact, the word oxidizing agent comes from oxygen. So what about this example? H2 plus O2 turns into H2O. So feel free to pause the video and try this example. So hydrogen gas on the left, it's in its elemental form, so it has an oxidation state of 0. Oxygen also has an oxidation state of 0. Now in water, in a compound, it's going to be different. Oxygen usually forms a -2 charge, and for hydrogen, when it's bonded to a nonmetal, it usually has a +1 charge. Now hydrogen, when bonded directly to a metal, typically has a -1 oxidation state, but when bonded to a nonmetal, it's +1. So now if we focus on the hydrogen atoms, we can see that hydrogen went up from 0 to 1, so therefore hydrogen was oxidized. Now oxygen decreased from 0 to -2, so because it gained 2 electrons, it was reduced. Reduction occurred. Hydrogen lost an electron as it went from 0 to 1. Now the substance that is oxidized is the reducing agent, and the substance that is reduced is the oxidizing agent. So we can see that O2 is the oxidizing agent and H2 is the reducing agent. So now let's work on our final example. Chlorite plus perchlorate yields chlorate. So go ahead and identify the oxidizing and the reducing agent. Now we need to find the oxidation state of every element in this compound or in this equation. Whenever oxygen is bonded to another element, typically it has a -2 charge. So for every oxygen that's in this equation, it's going to have an oxidation state of -2. The exception is if oxygen is bonded to fluorine. In that case, it's going to have a positive oxidation state, or if it's in the form of peroxide or superoxide. In the form of oxide, it has a -2 oxidation state. In peroxide, it has a -1 oxidation state. In superoxide, it has a -1/2 oxidation state. But we don't have to worry about that for this example. So let's start with chloride. Let's calculate the oxidation state of chlorine in chloride. So we have Cl plus 2 oxygen atoms, and it has a net charge of -1. So let's replace Cl with X, and let's plug in -2 for oxygen. So 2 times -2 is -4, and if we add 4 to both sides, we can see that X is equal to +3. So that's the oxidation state of chlorine in chloride. So now let's do the same thing but for chlorine in perchlorate. So we have 1 chlorine atom plus 4 oxygen atoms, and the net charge is -1. So 4 times -2 is -8, and if we add 8 to both sides, -1 plus 8 is 7. So that's the oxidation state of chlorine in ClO4. So now let's do the same thing for chlorate. You can probably see that it's going to be +5. But we'll work out the example. So we have Cl plus 3 oxygen atoms equals a net charge of -1. So 3 times -2 is -6. And if we add 6 to both sides, we can see that -1 plus 6 is +5. So that's the oxidation state of chlorine in chlorate. So now, there's 2 chlorate ions on the right side. So one of the chloride ions turns into chlorate, and the other perchlorate ion turns also into chlorate. So here, chlorine went from 3 to 5. So it lost 2 electrons, and the oxidation number went up. So therefore, the chlorine atom in ClO2 was oxidized. And the chlorine atom in perchlorate, it went from 7 to 5. So it gained 2 electrons. It was reduced. So reduction occurred. Therefore, the chloride ion is the reducing agent, and the perchlorate ion is the oxidizing agent. And so that's it. So now you know how to identify the oxidizing and the reducing agent. So I hope this all makes sense to you, and thanks for watching.